Thanks for being here tonight. We are excited to have y'all here. And like I said, if you're just joining, we're happy that you're here after a day of probably teaching or working a full day, and you are committed to doing some more professional development. So kudos to you right off the bat. That is awesome that you're here and ready to learn some more. This is the science behind the udder. And we are doing a short virtual forum series. We had one prior to this summer where we are taking scientists and researchers and people who are in the field and letting them share about the research that they've done, letting them share about science that they are experts in. And then our team, myself, Hannah, and Angela here are bringing in the teacher side of it. So, okay, there's this really great science, but how do we make it come to life in our classroom? So that is really the whole idea behind this virtual forum. So tonight, we'll chat with John and we'll let him share all about the research that he has and the science that he is an expert in. We'll give you some time to ask some questions to him. So as he is sharing, if there are any questions that come up, feel free to write them in the chat, drop them in the chat, or you can save them for our Q&A time. So either way, Angela and I will be monitoring the chat so we can kind of grab those. And if there's something that we want to pause John and have him answer right away, we can. Otherwise, if it's more appropriate to wait until the Q&A time, we'll do that. And then, like I said, we'll have some time for Angela and I, as curriculum writers and developers, to be able to show you how the science that John talks about can be brought into your classroom and brought to life. Um, quickly and with minimal work on your end. So we have some pre-made resources that will really be easy for you to implement, and that's what we know y'all want and need. So really quickly, like I said, my name is Hannah Wedger. I was a agri-science teacher for 10 years in Minnesota, and for the past 3 years, I've been working on writing a curriculum specifically in the NGSS space. And then I have my co-facilitator, Angela here. Angela is from Wisconsin. She just recently made a move to Illinois, but she taught for 16 years, specifically in the science space, 6th through 12th grade, and a whole gamut of science things. If you can think about it, she probably taught it. And she has also spent the past 3 years doing curriculum writing in the NGSS space. So, like I said, our goals really are for you with this virtual forum program, are for you to hear about the science behind and the research behind food and agriculture, and then how can you make that relevant and how can you bring that into your science education classrooms? We really want you to feel confident in bringing this really great information in and making it relevant for your students. And so that's why we're so excited to see 29 of you here tonight. And hopefully you can share this out with friends and coworkers who weren't able to make it as well. So without further ado, I'm gonna stop talking and pass it on over to Dr. John McNamara. We're really, really fortunate to have John here tonight because John is the best of both worlds. So John has a lot of knowledge and expertise in the science education space. So NGSS, all of that you can see on the slides here. He has quite the lineup of really being deeply involved in science education and the standards that are out there. But he also has a really deep understanding of animal science. And we love to see those two come together. And John's going to really highlight that for us tonight. So I am going to stop sharing and I will allow John to go ahead and share. And just remember, if you have any questions, feel free to drop them in the chat, and Angela and I will grab them, and you can save them for our Q&A time. So John, go ahead.
Great. Thank you very much. And I'll just stay on the screen for a minute before I share my slides. In short, I like cows. I like cows a lot, and I like milk and cheese and ice cream. And so I had an opportunity to study cows and work with cows through my entire career. And so I'm going to share you one storyline. I want to preface this by saying that this is much more just fun, factual background for you as a teacher, as a science interested person, not from my perspective, some specific facts and figures that you may use in your classroom tomorrow, even though you are going to get information and materials that you could use in your classroom tomorrow. But quite often in professional development, we just don't get the chance to sit back and think about where information comes from. And in my classes throughout K through 24, or however you want to count it, I just talked to students about scientists being people who were scratching their head trying to figure out how things work. And if we look at it that way, it becomes a lot simpler, a lot more fun. So what I'm going to show you, I've got about 20 or so slides. I'm just going to kind of breeze through them, kind of a stream of consciousness type of thing, on a focus on related to homeostasis, which I think you're all familiar with, and another term you're probably not familiar with called homeoresis. You may be familiar with the term allostasis in terms of equilibrium over a long period of time across multiple organisms. So with that, I will share, and because once I share my slides, I can't see any of you, so the host will take care of that. And then, so I'll need an audio signal from you that you can bear with me here a minute. So can you see the slides?
Yes, we can see your
Or,
slides.
okay. So,
John, your slides are, oh, now they're in presenter mode. Perfect.
yep. Okay. So think about mammals for a minute. And clearly, it didn't take humanity pretty long to figure out how to take care of their young. That little thing in the middle, somewhere in that pile of rat pups, is mom. And so humans make 500 to maybe 800 mils of milk a day to feed generally single child who's relatively slow growing. A rat gets pregnant 21 days later, has a litter of 8 to 12 pups who then provide them their sole nutrition. And by the time she's done, the pups outweigh her by a significant amount. And she has basically sacrificed her entire body of fat and muscle to that litter and then gets pregnant and does it again. And we just were able to see this. You can't actually see the calf, but there's a real whale that we just saw up on our Alaska trip. And a whale calf is born. The mother doesn't eat for 6 months, and the calf doubles its size in the neighborhood of thousands of kilograms. And then we have this lady. In case you're not sure, this is a cow. This was the world record holding cow. And you look at 700,000 pounds of milk in a lifetime. And you ask yourself, how did that come about? How can we breed and raise and feed an animal who can produce that much biomass that much energy and protein. And one of the things that I work with, of course, is the animal welfare and concern for animals, which are valid concerns. But I was asked by a group of European scientists to talk about cow comfort. And I said, well,
I don't know where you put on.
do you think a cow that's giving 200 pounds of milk a day for 300 days a year for 6 years isn't comfortable? That animal has to be well taken care of. But at the end of the day, then, how did we get to here? And some of you may have seen this on a cap of milk you bought from a certain place. No RBST. So what does that mean? So let's go start here. Some of you may have seen this experiment. The classic experiment is about 100 plus years old, but we've been doing this for 10,000 years. Big male horse, small female horse, big female horse, small male horse. How does that foal get told or know or tell the mother to grow the right size foal? And that's something that people has observed. So how does the size of the offspring at birth affected by the size of the mother? And what does the offspring tell the mother what to do? So you can find this. John Hammond was an eminent English physiologist of the early 1900s. An interpretation of results on animals in terms of the partitioning of nutrients in the maternal bloodstream according to the relative metabolic rate of the maternal and fetal tissues receiving the signals. Okay? Scientific work for how do organs talk to each other? How does the mother and fetus talk to each other? This is a very simple graphic of the priority of partition of nutrients according to metabolic rate. So we know that the brain has a very fast metabolic rate. It is the most important organ in the body from minute to minute. Bone, muscle, fat, if it's a growing animal. But what happens if there's a placenta and fetus? Now it needs nutrients and it gets nutrients, okay? And I love that first statement. The present state of knowledge on this subject is still in a rather nebulous condition consisting of a number of detached facts. In answer to the question, what determines the distribution or partition of the nutrients in the maternal bloodstream between fetus and maternal tissues? This is caused by the metabolic rate of the tissue. So this was very early on, not a whole lot of high-tech metabolism work could be done at that time, but it was a human observation that organs have to be talking to each other. Okay. And so he was one of the first to talk about long-term coordination between organs. He also was one of the first to use AI, and that's not artificial intelligence, that's artificial insemination, and which really changed the world in terms of breeding animals. And we also use the same basic techniques in breeding crops as well. Okay, in his work, this fact of metabolic rate controlling tissue metabolism, some substance, this is the way he worded, some substance, the fact seems to point to some limiting internal secretion or metabolic substance produced by the mother as a controlling factor in fetal growth. So this was his interpretation, his hypothesis. Possibly the key substance may be a glycoprotein. I just want you to remember that. So he knew that the organs had to be talking to each other through some physical thing, right? Nervous system. Remember, this was right when insulin was being discovered, okay? Is acceptable to special growth substances in the bloodstream. Something has to be in the bloodstream talking to different organs. Okay, I'm going to jump a little bit here. Now, lactogenesis was the beginning of milk production and induced lactation. From that time when Hammond set out those hypotheses, it really generated a tremendous amount of research. Estrogen, progesterone, glucocorticoids, insulin. The list of people who earned the Nobel Prize in physiology, chemistry, and medicine around steroids and hormones is a very long list indeed. Prolactin, which is the hormone which directs milk production. And so in the 1970s, somebody was actually working on a study to induce lactation to rescue dry cows. So where we gave them estrogen and progesterone, followed by this compound called reserpine, which induces prolactin release. And we could induce a cow to start milking within 3 weeks. So this was basically to help cows come into milk without having to go through a pregnancy. And so the point of this is in that 50 years from about 1920 to 1970, we discovered so many things about lactation and pregnancy. So now we've been going for about 6 or 7 minutes. I've been talking really fast and showed you a couple of slides. What have we already seen in terms of phenomenon, engagements, stories that could get a student's interest? Mammals, different kinds of mammals, pregnancy, fetal development, hormones, genetics, and homeostasis. How does the animal control all of these things? So all of these things are phenomena and prompts that you can use to make this, make the science meaningful for these students. So the next person I want to introduce is Walter Cannon. And you all know Walter Cannon directly because he's the person who defined fight or flight. He is the person who defined homeostasis. And this is without knowing what the hormones were involved, without knowing how it happened, okay? It's one of the first to use x-rays. He was one of the first to study hemorrhagic fever and shock. And in 1931, discovered what he called sympathin. And if I were live right now, I'd ask somebody to raise their hand and tell me what sympathin was named after. I'll tell you, the sympathetic nervous system. Something came from the nervous system which did things to organs to make them change their metabolism. And what he simply did by observation, that one change, so boom, a bear jumps at you, some of your organs shut down, like your intestines, and others turn on. Or more mundanely, when a female gets pregnant, some of her organs then turn into suppliers for the fetus, okay, instead of for themselves. So the fact that one hormone could elicit 2 different effects, that's really my take home here. How can one signal elicit 2 different effects? Okay. Some people don't think the 1970s are the modern era, but I do. So in 1972, I went off to college. And in 1974, I finished my bachelor's and master's degree at Illinois. And this was the title of my master's degree: Partitioning of Nutrients Between Mammary Gland and Adipose Tissue During Lactation in the Rat. This storyline from the 1910s to the 1974 could be told by anyone. It could be told by any scientist you meet. How did they come across this area of study? What was known beforehand? And I definitely urge you in your classes, as you're looking at teaching homeostasis or cell biology or respiration, whatever it might be, do the history, spend that time with the students and having them look it up. How did we get from A to B to C to D? Okay. And so I gave that presentation as a master's student at Michigan State in 1978. How do mammals adapt to both maternal health and offspring growth? Okay. So, in an experiment, you have to have a justification for doing it. So our justification was Hammond, maternal effects on tissue control, Cannon, 1 hormone, 2 responses. So our hypothesis was prolactin will initiate fat synthesis in the mammary gland and reduce it in adipose tissue to provide a homeoretic control of nutrient use to support lactation. Okay, what does that mean? That means one hormone will elicit two different responses, one in the mammary gland and one in the adipose tissue to support that physiology. So I literally had the University of Illinois scan my thesis into a PDF because the actual thesis was long gone. My major professor, who I'm going to introduce in a minute, spent his early career looking at the biochemistry of the mammary gland and the adipose tissue. And he discovered back in the early 70s two enzymes that make a cow a cow. How can a cow eat grass? The bacteria turn that grass into fatty acids, and the fatty acids be used for energy in the cow. And that's all that graphic shows, that metabolic adaptation. So the cow can use grass. Like we eat grass, but we don't use it. The cows can use it. So we did a very simple experiment. We had a control treatment. We had pregnant rats, and then we used this compound, bromoergocryptine, which can still be used by doctors to inhibit lactation and is used by doctors to inhibit lactation in women who choose not to breastfeed. And then we added back prolactin. So 3 treatments: control, reducing prolactin, and adding prolactin back. Very strict, answering the question, what does prolactin do? And so this was technology in 1976, dot matrix printer and hand-drawn graphics. But just take a look at that. The lower line is the lactation amount, the pup weight growth of animals whose prolactin was lowered. And then the normal control there is at the top, and then the line in the middle is the group with the prolactin added back. I'll leave that up there for a second. So we took normal animals and they produced milk. We took prolactin away and they did not. The animals could barely get enough milk. And then we added prolactin back and they produced milk again, showing that prolactin regulated milk production. This is just another measurement, a direct measurement of fatty acid synthesis. So I'm showing you 3 total slides. There were several in this experiment. And when you teach, you do that same thing. You try to get the basics of what's going on to your students. They don't need all the detail unless they actually want to be a scientist. Then they need all the detail. And this was the adipose tissue, okay? So just flip it upside down. If you took prolactin away, you see the adipose tissue, and I don't know if my cursor shows up, but this is the control animal. They just stopped making fat in the body, okay? This was when we gave them the bromocriptine, or when this is the one where we gave them bromocriptine and they started making fat again. And then this is the one where we gave them the prolactin. So bottom line, prolactin made milk synthesis go up and body fat synthesis go down. Okay. So that was that thesis. All right. We took one hormone away and mammary tissue was inhibited. Adipose tissue was stimulated. And we showed for the first time that a hormone not adrenaline or noradrenaline or epinephrine or norepinephrine could have this effect. And you think, okay, how have we been going? We've been going about 15 minutes, 20 minutes. What's this about? Somatotropin and war. Well, somatotropin, growth hormone, we knew that it could regulate milk production back 70 years ago, and they thought the Brits could use it to stimulate milk production to feed people during the war. It worked, but it was too expensive to use. There weren't enough pituitaries to grind up. Okay. So I've jumped from prolactin to growth hormone. These are very similar hormones. And in the cow, growth hormone regulates milk production as much as prolactin does. Okay. I think probably all of you have heard about Rachel Carson. Rachel Carson was a well-known early generation environmentalist in the 40s and 50s. She wrote a book in 1961 called Silent Spring, calling out all the practices that were poisoning the soil, the water. And she was right. We were using chemicals badly. We were using chemicals that were much too strong. And that stimulated a lot of research. That stimulated a lot of funding, a lot of research. And Monsanto in the 60s and 70s had showed that you can increase milk production using somatotropin, but it was too expensive. A young fellow by the name of Dale Bauman grew up on a Michigan dairy and started his professorship at the University of Illinois. I was one of his first students. We want to help feed people. That's why we're here. We want to use naturally occurring hormones. We know that animals that are more efficient are better for us, better for the planet. And he read the literature. He read about John Hammond. He read about Walter Cannon and hormones. Hormones control nutrient use. And one of the things that he did, and others at the time, and this is so important for you in the classroom when your students talk about this, they're showing interest. No one thing stands alone. You have to have an appreciation of the big picture. When you hear about all these great, wonderful discoveries, it's because that person or that team of people read the literature and knew what was going on before they did the next experiment. So that was when we were learning that nutrition and hormones go together. Okay. All right. So the new technology. So this was new technology in 1970s, recombinant DNA. In short, we can identify a sequence of base pairs, put that into bacteria, and the bacteria then would make hormones for us. So the first one was insulin. No big surprise there. The very first hormone that we made through recombinant technology was insulin. And so diabetics did not have to rely on pigs and cows to provide insulin for them. What was the second one? Somatotropin. So this was the study done, partitioning of nutrients during pregnancy and lactation, a review of mechanisms involving homeostasis and homeoresis. I'm going to show you one more experiment and then we'll wrap up. Bovine somatotropin. Does bovine somatotropin increase milk production? Can we use this as a way to improve milk production naturally using bovine's own hormone? Very simple experiment, 4 cows with a sham injection, 4 cows with BST. If you look here, right here, got about a 4-pound increase in milk production in early lactation. If you do the math, that's about a 15% increase. In late lactation, you got a 4-pound increase in milk production, but that was about a 35% increase in milk production. Now, I know I'm throwing a bunch of stuff at you quickly, but here's a table from a study that was done that showed a 35% increase in milk production by somatotropin. 8 cows. People immediately took that. Now, again, this is pre-internet. This is literally all newspaper, magazines, word of mouth, radio. That was the speed of transmission. It wasn't social media speed of transmission. And within a short amount of time, people were convinced that somatotropin is going to increase milk production 40%. We're going to flood the world with milk. We're going to destroy cows. That was what happened. Okay. He gave that talk right here in Pullman in the classroom that I was then teaching in. And he was criticized by scientists for using too few cows for that study. They used the entire world supply of somatotropin for that study. We needed to have a way to make somatotropin to help cows, recombinant BST. So we took natural cow somatotropin, put that sequence into bacteria. The bacteria made bovine somatotropin. And this was the study that showed the dose response of increase in milk production. No fancy graphics, black and white. We could increase milk production with recombinant bovine somatotropin. That was 1984. In 1994, it was approved for use by the FDA. It was approved by every single agency, public and private, that had anything to do with human safety and nutrition. Okay, so think about that for a minute. A 50-page document with 10 to 15 references per page. That was how much work was done on somatotropin in that 10-year period of time. So it was approved for use in 1994. At that time, the then vice president of the Washington Dairy Foundation took money from the organization without permission to place full-page ads out. We don't want hormones in our milk. And as scientists and science teachers, I want you to think about that for a minute. We have known for quite a while that there are roughly 80 different hormones in milk. There are about 40 in soybeans. There are hormones in everything we eat, and they're naturally occurring, okay? But that's where we were. It's approved for use. It is used in some small amounts, but in fact, people were worried about using recombinant bovine somatotropin. But that technology still exists. It's there. And we use it for all the other hormones that we want to use. Okay. So that technology is there. We can use bacteria to make human or bovine hormones. Okay. So thank you for that. It took, what, 25 minutes? What have we learned? What do your students care about? For those of you that are in the classroom, or you're a state specialist or district specialists, how can you grab their attention? And I hope I've given you some things to grab their attention to help them think about how we do things. And then I know you can do it in terms of transferability, transfer tasks, and things like that. How can you use other things that you're interested in, other areas of food supply, that you can draw a similar timeline? Okay. And you can use various internet techniques to help build that timeline, and I'd be happy to help you with it as well. So with that, I think we'll hand it over to Hannah and Angela, and I can stop sharing.
Thanks so much, John. This is the time now where if you have questions for John related to the storyline that he shared, or I would say that John would be willing to ask some of your questions too about how do I bring this into my classroom? What are your thoughts? Now's your time. So if you'd like to unmute and ask, you can absolutely do that, or you can message Angela or myself, or put it just in the general chat.
Hi, I'm so sorry. With the weather that we're having, I can't do video and
That's okay.
audio at the same time.
Yep. Go
I'm
ahead,
just
Maria.
I'm just curious, John, do you have any books or anything that you've written if we wanted to read more about it?
Got some summaries I've written. Actually, it's funny because sometime later this year, hopefully I'll come back and talk about pet nutrition, because the book that I actually wrote was a textbook on pet nutrition. But I do have some summaries that you can read, and I'll make sure that Hannah and Angela get those, okay?
Yeah, and
Some,
the pet nutrition would actually also be awesome because I'm currently teaching seventh grade students, and so they love all of that. You know,
okay,
they're all about the animals.
I can provide access to that. And so and this is one of the things that I would just encourage you. Again, I know with seventh graders, there may be some procedural issues there, but it's something that you could easily do a internet search on
Yeah, for sure.
and, and get some good information there. But I'll definitely get that to Hannah and Angela.
Thank you so much, sir.
How milk is actually made. Yep, we can, and I think they're going to show you some of those. Angela and Hannah have some references and lessons that address your question, Dana, as well.
John, we had a question that was privately sent. It says, looking back, what do you see as the biggest success and possibly the biggest limitation of RBST research?
The RBST research showed a couple of things. It showed that you could, on an industrial scale, make large quantities of a protein using the bacterial technology. Now, step away from hormones for a minute. Just think about proteins, proteins that we want to eat. Okay. We know that we can actually make bacteria and now fungi and things like that make proteins that we can eat to help improve the food supply. Also, it showed this was the very first, after insulin, again, insulin being clearly extremely important, that we can make proteins this way. One that I'll tell you about is called protein C. And protein C is one of the proteins involved in blood clotting. And 1 in a million children are born with a protein C deficiency, and it's horrific. It's terrible. And we can't gather enough protein C from all the blood. If we used all the blood that we collect in the Red Cross or other organizations, it wouldn't be enough. So there literally there are cows now producing human protein C in their mammary glands, and then we purify it to save those babies. So that is one of the technologies that came out of that.
Okay, John, I have another one that was sent. It said, are there misconceptions about hormones, milk production, or biotechnology that you often encounter, which you've kind of talked about, but then their follow-up question is, how might educators address them?
Well, the way to address them is just show them the facts. If you're able to bring them to a farm that you've checked out first that they're doing things correctly, that's one way. Using and every unit, whatever state you're in, your land grant university has information on that, and you can look it up at your land grant university, or organizations like the American Farm Bureau, the American Dairy Science Association. These have proven, vetted, peer-reviewed information that you can use on what are best practices, how are animals really raised. And there's been many examples of things that we've changed, things, how we house animals, how we handle animals, those types of things. So I think, your first source would be your local land grant university, your state university, with an animal science department. And then from there, again, the various different organizations that, and I'll use the American Farm Bureau because they're a pretty well-known agricultural organization. When they put something out, it is checked. Okay. It is vetted, it is checked, it is reviewed, it's curated, it'll hold up in a court of law. Okay, that's how I taught my students. You don't know that when you go to Joe's Be a Vegetarian website. Okay. And so that's something we have to teach, for first resources for our students. Thank you for that comment, Jane. That's reality. So I don't know if you want to move on to, because I can answer questions all day, but
Yeah.
if you want to show them some of our resources.
Yeah, I was gonna give everyone one last chance if you want to unmute and ask a question. Okay, I had one last one, John, and this I think is a good segue into our resources. If you were designing a phenomena-based lesson from your research, what driving question would you want students to investigate?
You like ice cream? Do you like pizza? So I would start there. I would
Yes,
start there.
each
Do you
side.
like ice cream? Do you like pizza? And what have you heard that's wrong with ice cream? Or what's wrong with pizza? And then you can start that conversation. The other one, if you're more of a, I want to be more specific, just, talk about homeostasis. How can people live in environments as different as, the Arctic or the tropics, those types of things. As one of our participants just said, they knew someone with protein C to be. Everybody knows someone who's diabetic. Okay. So I think that would be a very simple, phenomenon. How can diabetics have a vibrant, healthy life? Those types of things.
Awesome.
I'll
Well, if
come
there's
back to your question later, Eugenia. Okay.
Alrighty. Um, we are going to go ahead and get started here then on the second half of our forum. And I put this up in the chat as we started and as John started talking, but this is really the part where we're going to engage y'all. So feel free to kind of get into a space where you can unmute, you can type in the chat, that sort of thing, because we want you to be engaged and really be able to kind of get something out of this to be able to bring back to your classroom tomorrow and implement it if you so choose. So I'm gonna pass it on over to Angela, and she's gonna kind of bridge the gap for us from John into our resources.
Yeah, thanks, Hannah. So I did just a couple moments ago drop a document into the chat. It's called our takeaway doc. And we wanted to share that with you before we moved into this next section, because this next section, like Hannah said, is kind of, we're going to be doing a lot of different things and a lot of pieces. So if you just pull that up, you'll have access. There's at the very top, there's the webinar docs. Those are all of the things that John has put together, like his slideshow. So you have access to all of the different figures and charts that he shared and showed. And then he's had some suggested materials that he wanted to share with you as well, which are all there again in the webinar documents, and they're all linked up there. Then we put together a timeline of some of the experiments that he kind of stopped along the way to share. And then we also did summarize his presentation as well. And the reason that we do that is just because sometimes the material can be a little complicated, or maybe it's like a month from now and you're like, I don't remember all those details and exactly what happened. And so you have that as kind of a resource when you're working and when you're planning. And then directly underneath that is the takeaway documents. And so these are going to be things that we're going to be using in our next section here. So don't worry if you're in your car, or if you're, at a football practice, or, there's something where you can't access. You're going to be doing some breakout room work, and you could just share that with the people in your room. And we all understand that, life happens, and we appreciate you being here and giving your time to us. So those documents will kind of walk you through as we get to them. And then we did link the entire unit that we're going to focus on there at the bottom. We put the table of contents as well as the unit guide, which just gives some more information. That second page where it says module 2, we'll get into that a little bit later. That's going to have all of the links that you need for one of our breakout activities. And then John brought them up already as well. But for those of you that really need to focus on those 3 dimensions of NGSS principles, we did put in the performance expectations. The science and engineering practices are there in blue. Our disciplinary core ideas are in that orange color, and the green is representative of the cross-cutting concepts, all of which are related to this module 2 activity that we'll do later. But just wanted to take a moment to show you kind of like what you've got in front of you. So if we reference something, that's kind of what we're talking about there. So yeah, so let's take a moment to just kind of like reframe our understanding and our thinking. So John talked about a lot of moments in time as he shared this story. And one of the things that we found when we were meeting to prepare with Dr. McNamara was this idea of like, stories are so good at getting students curious, right? Especially in science. And I think he did a really good job of telling that story and then also like helping us to recognize like, yeah, that's a really great way to teach some things. So we're going to take a moment to kind of reflect on just 2 moments in that storytelling. And the first one is when we were talking about extracting those pituitaries, and he was talking about there just weren't enough to grind up, but man, did it work. Like we saw increases in the production. And then compare that to when we get to 1980s and we're looking at the, literally bacteria are able to produce this bovine hormone, and that's pretty fascinating. And so that's kind of like the frame up here of our next set of questions. So think about those 2 moments in time, those specifically, and you can drop your responses to any of these 3 questions that are showing up here on your screen for you in the chat. We have one that is related to what kinds of science skills were needed for the scientific breakthrough. What kinds of NGSS standards? You don't have to go like, ESC 1.439. Like, no, we just need you to give us a topic area. That'd be fabulous. And then thinking about our cross-cutting concept pieces, which again is so important in those 3 dimensions and kind of often gets kind of pushed aside sometimes, is what do those aspects of that story, those 2 different moments in time, what kind of potential connections do you see to other content areas? So just give you a moment. If anybody's super brave and wants to chit chat, you're more than welcome to come off mute and share. Otherwise, we'll give you a moment to drop some thoughts into the chat, and we'll, leave those up there for you to think about. Speech and debate. My high schoolers, that's all they ever wanted to do was debate. Everything could be turned into a debate. So love that idea. Yep, climate dynamics definitely seems to be a very important one. Genetics and human impact. Awesome. Thanks again for sharing, everyone. You can keep dropping some ideas as they come in the chat. Yeah, engineering and testing solutions, asking questions. Awesome. Cancer and cures. Yeah. Oh man, gold star right there on homeostasis and genetics, because that's kind of what we're gonna lead you to next. But I love the math and career connections pieces. Yeah, math, sometimes we forget how much I taught physics primarily, so I was always doing math, but yeah, there's so much math that's involved in science, so for sure. Oh, love that, Elizabeth. That's great. Awesome. Okay, well, you can continue to keep dropping ideas as you have them in the chat. Again, we want this to be your webinar and be as interactive as you want to make it. But we'll go ahead and we will move into our next piece, which is where we are going to put you into some breakout rooms here in a moment. And on your takeaway document, in the takeaway documents section, the very first takeaway title is Walter Cannon and the Story of Homeostasis. And so this was one of the people that John shared about in his presentation. And so super excited to kind of give you a little bit more details about that story of how this all kind of came about. And we're going to send you into a breakout room here in a moment. And on that handout, there is a story about his work. And then the second page of that document is going to have some discussion prompts that you can use that are related to some of the critical thinking skills. So, yep, so it's that first one right there. And again, it will have those prompts on that second one there. But what we're going to have you do in the breakout room is just use a couple of those prompts. You don't need to, go into, there's a lot of them, so you don't need to go into all of them, but maybe there's a specific science skill that you're really trying to work on with your students and trying to really spark some innovation with them. And then consider how your students might be able to learn from stories that are like these about innovation and creativity. Okay, so we're going to go ahead and we will send you into a breakout room. You can say hi and introduce yourselves first. And then what we'll do is we will stay here in this room in case you have any technical issues or anything and you need to return back. You can hit us up here and then we'll give you a shout out when we are kind of running with a couple more minutes left. Okay. Any questions before we open those breakout rooms? Okay, well, we are going to go ahead and open those rooms. And again, let us know if you have any trouble and we'll pull you back here when we're ready to move on and discuss. I'm going to mute and let you do your thing and I will close these rooms.
Okay, we'll bring all the folks back.
Thanks.
All right. This time we truly did want to bring you all back. It wasn't by accident. We did want to bring you back this time and hear what you had to say. So is there anyone that wants to share just what you chatted about in your group? Any of the prompts, anything that was interesting that you'd like to share with the rest of the group? You can go ahead and unmute.
We got off to talking about global warming because we had people that had an ag background and how we could bring that in and debate about that and get resources to show about agriculture isn't the main use of global warming.
I love that. It's always good when you have a group of teachers and you can, kind of think about and chat about what does this look like in this context? How can we bring it in this context? That's really the beauty of being in a breakout room with folks. Is there anyone else who wants to share? Okay, well, we're going to get into the meat and potatoes of some resources that we want to share with you tonight. Some of you in the chat talked about Media Mayhem, which is one of our units that we've done and might be a good one to get into if your kids are interested in the media and different claims that are being made about greenhouse gases and dairy production. Possibly a great unit. That's not one that we're going to focus on tonight. Tonight, we are going to focus on the post-game analysis unit. And just a quick summary of the unit. Students are investigating how chocolate milk, can help in recovery from intense exercise. And so in this unit, students are really observing professional athletes, observing them undergoing like intense exercise, drinking milk, and then how does that help the body recover? And so it leads them to the driving question for the entire unit, which is how can milk help athletes recover from physical exercise? The reason that we chose this is because it gets into feedback mechanisms, which connects to what John was talking about in that homeostasis piece of the puzzle. So we're going to jump into module 2 tonight, but what we wanted to do is tell you in module 1 of the unit, students really understand how does the body digest milk, okay? And so that is what they're figuring out. Someone drinks the milk, what happens from the mouth to when it ends up in the toilet or the stuff ends up in the toilet afterwards. What's getting absorbed? How is it getting absorbed? Where is it going? All of that. So then we get to module 2, and we have some questions in the module that are driving our learning. They're, why do we get sweaty and thirsty after exercise? And why does the color of our urine change? And how does milk help us recover from these effects? So these are some of the questions that are driving the student learning. And so we're going to start with lesson 8, which is the first lesson of this module and really the investigative phenomena. So we are going to have you kind of put on your student hat, and you're going to experience this from the student point of view, and then we'll talk a little bit about it from the educator point of view. But we want to think about these questions that I just talked about. Sweaty, color of urine changing, you're getting thirsty. Why does drinking milk help us? And so if you're a student, we're going to have you watch this video, but they have a space where they're going to record what's happening to this athlete as she is exercising. So what's before, at the end of exercise, after exercise recovery with milk, and then after exercise recovery without milk. So I'm going to go to this next screen so it's a bit bigger. And I'm going to play the video, and you can certainly pretend like you're a student right now and jot stuff down if you'd like. Um, with what's happening before, at the end end of exercise recovery with milk and without milk. So without further ado,
I'm Katana, and today I'll be doing an intense cardio workout for 30 minutes. I'll be describing how I'm feeling throughout the process for you to learn how my body is impacted by exercise. Right now, I'm starting to feel a little out of breath. I'm feeling thirstier now that I'm working out. My body temperature is definitely increasing since I began exercising. I just finished my workout and I am tired. I'm feeling really, really thirsty, and my temperature has definitely continued to increase. It's been about 20 minutes since I finished my workout. I'm still tired, but I've stopped sweating, and I'm still feeling thirsty. My temperature has returned to where it was before I started my workout. It's been about 20 minutes since I finished my workout. I'm still a little tired, but I've stopped sweating. I'm not feeling very thirsty. My temperature has returned to where it was before I started my workout.
all right, so we have our sweet Katana here. She did her workout. And what we would expect is that students would fill out the table with some of this information. They might not have all of it. All of this information was in the video, but this is what we would hope that they would write. And the idea is that we are hoping that students would at this point say, okay, we figured out exercise is causing some changes in body temperature. I'm sweating. The person was sweating. Like, we know that exercise causes sweating. And when I went to the bathroom, the color of my urine maybe changed. We also probably can expect students to know that drinking milk seems to help them, like an athlete, recover after working out, and these body changes bringing them back to normal. So these are the things that we can expect students to kind of know. Now, what they don't know, and what they should probably have some questions about at this stage, is why these things are happening. Why is body temperature increasing? Why am I sweating? What is causing that? What is causing my urine to change colors? Like, what are the mechanisms that are happening that are causing these things to happen? So, in the takeaway document that Angela shared, there is a Padlet. It says driving question board Padlet activity. So, if you want to go ahead and click on that, you should see a big screen and you should see some folks that have wrote some questions already to get you started. Your job is to add any questions that still need to be answered. So when we look at this, we look at what we figured out. What are the questions we still have? So go ahead and take a moment, go to that Padlet, and you can start asking questions. And for the sake of time, we'll just stay in the big room here right now, and we'll just let you ask some questions. Think about what are the questions your students might have after they've watched that video. They've watched Katana run. They've seen some information. They got some information and data about numbers changing. And so what questions might they have? So we have some, from the humble leopard. I love when it does that. How is milk different from water or Gatorade after exercise? How do the nutrients in milk help us recover? Why do we feel thirsty while working out? And how does milk relieve this? Why does milk make a difference in recovery? Why do we get dehydrated when working out? What causes you to feel thirsty? Why do we sweat? What other questions do you have? It's telling me some people are typing right now. What does losing water have to do with sweat, thirst, color change, urine color change? How does milk quench thirst? Good, good, good. Okay. So if we were in the classroom, we would hope that our students are coming up with these questions, right? We're creating a driving question board, putting all the questions up there. And then at this point, we might start kind of grouping some of these questions together. So if you look up here, there maybe are some that are kind of somewhat similar. So like thirst, I see is like what causes you to feel thirsty? How does milk quench your thirst? We have some questions about sweating. We have some questions about like what are the things in milk that help it make a good recovery drink? Maybe identifying like what are those things in Gatorade? Are those things in water? What are the differences? So that's something that we might do at this point to then bring us into the rest of the lesson and into the rest of the module. So our next kind of stop along the way here is why would we use homeostasis phenomena as the phenomena? And I'm going to hand this over to Ange because her expertise and background in science allows her to answer this much better than I can.
She doesn't give herself enough credit, you guys. But kind of tying back to kind of why we had Dr. McNamara here giving his discussion earlier and presenting his research before. Um, Obviously, we all know, like in science, at least I know in the schools that I taught in, like standards kind of guide what we have to do, right? So we know that there are standards related to specialized cells. We know that there are standards related to human systems. We know that there are different DCIs that are related even to like how different pieces and parts break down in the body and what they started as and what they become. And so homeostasis and the idea of like digestion through of milk products and this idea of how milk can help with exercise recovery is a great way to bring in those DCIs. It's just a also one that I think some of you had even mentioned, even in the Padlet, like people are curious about like what else does that and why this over that. So they can get a little bit creative there. And then engagement with a scientific phenomenon is really a great way to just spark interest and curiosity. It can help them make connections to existing information that they already have. And we also rely really heavily when using scientific phenomenon, particularly related to agriculture. They're looking at observational skills. And so really focusing on actual science skills that are important that they need to be developing. And then also phenomenon-based approaches are going to increase student sense making because again, they're connecting their own lives and human activity and all of the different things that happen in and around them to all of that scientific content that we're kind of required to teach anyways. So it kind of works out pretty nicely. So we'll just hang out on this slide here for a moment because I'm going to punch just in the interest of time. And so we are going to have you look at a tool called the lesson integration tool. And one of the things that we think is really important when we do these presentations is like, cool, thanks for all of this material, but like I now need time to figure out how in the world can I even use all this cool stuff? Like everything that Dr. McNamara presented, everything resources wise that Hannah and I are sharing with you, like you have access to all of it. And so that could just be really overwhelming if you don't take a moment to just put together, like, how in the world am I going to use this? So on the takeaway document that you have a tool called the Lesson Integration Reflection Tool. And when you click on that, it's going to ask you to make a forced copy. So that way you have your own working document of this. And so what this tool is it's going to allow you an opportunity here, and we'll show you where to grab the resources for it, but we're going to show you a series of the rest of the lessons in this module. So we only showed you that video that was the investigative phenomenon from lesson 8. And in the time that we have remaining, you're going to sit here and kind of individually think through all of these other things exist here with it and relate to what we heard from Dr. McNamara in the beginning and what we know we're already doing in our classrooms. And so this tool is just meant to help you kind of like personally reflect on some of the pieces and parts that we have available to share with you. So if you, as we mentioned earlier on that takeaway document, if you keep scrolling down, you're going to see all of the module tool components on that second page. And that link right there on the right-hand side is going to have you access a folder. And that folder will have all of our teacher materials, all of our student materials, the like quote unquote answer key that we have as well. And so we're going to just give you a moment to kind of live in this space, pick one of the lessons that you think is the most engaging to you. To give you a little frame of understanding, we did put a little synopsis kind of on there as well. But for some of you, this might be the first time you're seeing any of this. And so we just want to sit in this space for a little bit and give you a chance to think about how you might be able to use it in your classroom. So I'm going to stop talking there. You're going to open up that lesson reflection tool or at least kind of think about some of the pieces, and we'll give you an opportunity to hop into some of these lesson components, whatever, you know, sparks your interest. Um, just for frame of reference, if you're familiar with the 5E model, these follow those 5Es. So um, that might be helpful if you want to decide where you want to pick. So again, I'll stop talking. We'll give you a moment to mess around with these materials and fill out your tool. And when we start talking again, we'll give you more instructions towards the end. Great question, Brooke. I can answer that for you. If you go to where it says post-game analysis unit at the bottom of the first page of the takeaway doc, there's a table of contents there. And if you pull up the table of contents up at the top, Hannah, the first page, bottom of first page. Yeah, if you click on that table of contents, which is that first link, that'll take you to all of the module. So, or all of the modules. So it'll have lessons 1 through, I forget how many we had for this unit, but there were a lot. I think there were like 30. Yeah, 32. There you go. And then also, as you guys are working, yep, this document is yours. You are more than welcome to make a copy of this takeaway document. We will add some of the pieces that John shares after with us. But yeah, this is all yours to look through and access. We won't change a thing other than that. You're welcome.
Take about a minute more to kind of think about and look through and explore. Um, and I will ask for one or two folks to kind of share what they saw, if there's anything that they might want to bring into their classroom. So if you want to share that in the chat now, or if you want to think about what you might say at 26 here, we'll come back together. All right. I'm curious if there are folks who want to unmute and just share any of the things that you noticed in the module, anything that you might want to use in your classroom. And if you were like, that was not nearly enough time to figure it out, that's okay too. I am going to go ahead and share. Dawn, it looks like you had a question about module 1, possibly. No, we got it, all of the modules. For those of you who maybe want to look at a different module just one more time, in the takeaway document, if you look at the post-game analysis table of contents here and click on it, all of the lessons are here. So if you have a space where maybe digestion of milk might fit in better, those lessons are here. We have module 2, which is what we talked about with the feedback mechanisms. Module 3 is the internal processes of recovery. And then module 4 is how do our muscles recover? So our muscles get sore, how do they recover? And then the performance task is here at the end. All right. Well, as we wrap up tonight, I just again want to say thank you for being here. We appreciate you taking the time to hang out with Dr. McNamara and Angela and myself, learning some more in the name of helping your students learn some more and learn more about how we can use science or how we can use agriculture as a way to teach science, because agriculture is science, really. It's deeply embedded. Before you leave tonight, there is all of these resources. So the post-game analysis, I also chatted about media mayhem, which I think based on some of the conversations may be a really good fit for some of your students as well, are located on the food and agriculture the Center for Food and Agriculture Science Education, and it is this link here, as well as if you want to grab it with your phone, the QR code will bring you there. When you click on that link or get it, it will go to something that looks similar to this. So you'll see that the post-game analysis unit is here, but also media mayhem is there as well. And then we have some about genetics for beef cattle. So these are full units. We have transfer tasks. We have phenomena that live there as well. So there's some resources that are free. And like John said, they're third-party vetted. So they're vetted by the USDA for accuracy, but they're also vetted by another group to make sure that the science concepts and how we're teaching them are accurate. So it's super exciting that they're available free for you. And then the other thing we would love for you is to get a survey. Just what did you like about tonight? What did you not like? Just to get some information from you. So we would appreciate before you log off to take that really quick survey so that we can do more of these and make sure that they suit your needs. So without further ado, thanks for being here tonight. We appreciate you, and we will hang around for just a minute or two if you have any questions. Take care.
I do have a question. I'm sorry to
Yeah.
bother you.
Nope, go ahead, Maria. That's why we're here.
Well, no, it's I wish it was an interesting question, but it's a more boring one.
That's okay.
Do you guys know if we get a like a completion certificate that we can show our department heads for like PD credit?
That's a great question. We